today's third session. Today we are having two personalities for this session, Dr. SN Teli and Dr. DS Gowli. So first of all, let me welcome Dr. SN Teli sir and let me introduce him. Dr. SN Teli sir is presently working as professor in Bharati Vidyapeeth College of Engineering, Navi Mumbai. He has completed his PhD from VTU Belgavi and MTech Mechanical and B in Mechanical with gold medal. He is having 23 years of teaching experience in which he has worked as HOD, Dean and also in charge principal. He has published 10 design patents and more than 125 research articles in reputed journals, conferences, having 300 citations, and he also published 20 books. He holds technical session chair for international conferences at IIM Tirchi, NITI Mumbai, SPJ in Mumbai, Amity University Mumbai, etc. He has given more than 50 invited talks on IPR, Industry 4.0, Mechatronics, control system, etc. He has guided more than 30 PG students. Also, he has been awarded, received many awards for outstanding contribution in academic and research, also academic excellence award, also research award. So with this brief introduction, once again welcome Teli sir and request him to continue. Thank you, sir.
Thank you.
Sir, have you shared your screen?
Sir, just now as
yes, it's visible now, sir.
It's visible. Yes, it's visible.
First of all, I'll thank to Walchand College and Third Engineering College. Especially, I thank to Gowli sir, Arali sir, and Suhas Deshmukh sir. Today, they have given me opportunity to share some information to these two participants. So now I'll start a Mechatronics virtual lab. Here, this free downloaded software. This is called a Fluid Sim. Fluid Sim and Festo. Festo, it is a German company. It is freely available on the website. I have downloaded when I was in KIT Kolhapur nearly 15 years back. I have downloaded same software till today I am using. So in this software you can do a practicals of pneumatics, electro pneumatics and hydraulics, electro hydraulics and PLC program also. And a very small software you can even you can copy and paste also. Now I have not installed, just you see that just you copy paste in a very small MB. So any student you can use even at the low configuration PC also. So here you can learn self-learning. I have learned myself actually. It is very simple. Here library is there. In the library and below their names are there. For example, suppose double acting cylinder. I can take a double acting cylinder. And even if I click this, I can go for parameters. How much the stroke? 100. Now I can change the stroke also. External load. Many options are there. For example, basically I'll go, suppose sensing I can remove, cushioning I can remove. This is a double acting cylinder. Then how to control this double acting cylinder? By using valves. These are called direction control valve. Suppose this is a 5x2 valve. Here the variety 4x2, 2x2, 3x2 varieties are there. Here it is called 5x2. You know that there are 5 holes or ports in each position, so that it is called 5x2. The pneumatic, usually we are going for 5x2. The hydraulics going for 4x2. Here first I'll show by manually. Suppose I can, here if you double click on any component, it shows all the features of that particular component. Now compressor is required. This is for symbol for compressor. Below they have written compressor also, and give the pipe connection. And here I'll give the muffler, that is called exhaust system. So to reduce the sound, okay, silencer, okay, Now I'll go here. There is a one more option is animation. This is very important. You can understand. Okay, while animation, there is a, if any problem in the animation. Okay. So here there is an animation. Now if I press this, it is extending. If I press this, it is retracting. And now we can see the velocity also. Just I'll click this parameters, velocity I can keep on. You can see the velocity also. So it is very fast. So what I'll do, I'll reduce the flow. Instead of 1000 liter per minute, I can go for 1 liter per minute. Then the speed is reducing 0.05 and 0.06. Usually the retracting velocity is greater because this side area is less. Okay, Q is equal to AV. Now this is a pneumatic. In the pneumatic, we can go for pilot operated and operation and or operation. You can do many operations. Suppose I'll go for automatic. Now it is a manual. It is a manual. Okay. So student perspective, you can understand now whatever I have designed, this circuit is right because it is working now. Now what I'll do, I'll go for limit switch. The limit switch are nothing but what pneumatic limit switch. It is not an electro pneumatic. Say suppose S1 and S2, you can give any name. Starting of the piston and end of the piston. Okay. Now this S1 and S2 are the limit switch, mechanical switches, contact type of switches, and pneumatic switches. Now here I'll go for next option is mechanical, and I'll remove the manual operation. Manual operation. Here I'll write S1. When S1 is on, S1 is on. Now it is the dashed line means what? S1 is on, and here S2. When the piston end reaches to S2, it should be on. Means the piston is retracting. We'll see in the animation, it goes to S1, S2. It is doing automatic. This is called industrial automation and pneumatic automation. Here no anything electronics involved. But basic pneumatics you can understand what is the extending velocity, retracting velocity, and S1 and S2 are the two limit switches. Okay. So now same thing I can go for electro pneumatic. Here there are a lot of you can go for two piston and cylinders, sequencing circuit and all. Because due to the shortage of time, what I'll do, I'll go for electro pneumatic. For electro pneumatic, I'll go for solenoid valve. I'll remove this mechanical. So pure this electro pneumatics, pure pneumatics till today people are using in paint industry and some chemical industries, but other rest of the industries they are using electro pneumatic as well as mechatronics. So solenoid valve, say for example A plus means what? The piston is extending. A minus means what? Piston is retracting. Okay, and here S1 and S2 are the sensors. Okay, it may be proximity sensor, it may be capacitive sensor, it may be magnetic sensor. I can keep here. Okay, these are called reed switches. Okay. Now how to operate this by electrical circuit? So electrical means 24 DC volt is required and 0 volt is required. So S1 and S2 are the sensor. So I can take S1 is a sensor, make a switch. Here he has mentioned make a switch, and here S1 and the solenoid valve, the symbol of solenoid valve. This is the symbol of solenoid valve, and here this is A plus. You can give Y1, no issue. Usually standard is A plus is extending, and A minus. So make a switch. S2 is a one more sensor, and here one more solenoid valve, that is called A minus. That is called A minus. Okay, now the electrical network is over. otherwise electrical ladder is over, and pneumatics. Now you see the animation. Automatically, when it goes to S2, this solenoid valve is on because the 24 volt is coming from S1 and S2. S1 and S2 are the inputs, A plus A minus are the output, and final output is the motion of the piston, extending and retracting, actuator. Okay. So this is the electro pneumatics. Here I can use a delay time by using relay. You know, relay is a single input and multiple output. Okay. So now I can use a relay also. Suppose I want here the timers are also available, OnDelay timers. Suppose when it goes to S2, it has to delay by, for example, OnDelay timer. Okay, it has to wait for some 4 seconds. Okay, you can change the timing also, delay timing. Now it is 5. I can go for 4, and label is T for timer or T1, T2, whatever. And after this timing, there is a make a switch. After this timing, after 4 second delay, when the piston goes to S2, the timer starts, but the timer will give the output after 4 seconds. After 4 seconds, the A minus solenoid valve has to on. So here I'll mention A minus. So now I'll go for animation. When it goes to S2, it has to delay for 4 seconds. After 4 seconds, it is coming back. So you are understanding from this software, the on-delay timer, off-delay timer, how the system is behaving, and you can go for n number, minimum 100 exercise you can do it. Already I have uploaded on my YouTube, Dr SN Teli YouTube, 20 programming circuits, Mechatronics as well as Electro Pneumatics as well as pneumatics. Many 2-cylinder, 3-cylinder, 4-cylinder problem also I have solved. So this is the on-delay timer. Now, I'll focus on there is a PLC actually. The third one, you can use a PLC also. So here, it is a PLC is interesting. Our lab also there is a PLC, but in the COVID situation for this semester, at least we can do the practical virtually. Here there is a PLC. PLC is a black box. Here I1, I2, I3, I4, I5 are the inputs. Q1, Q2, Q3, Q4. Some PLC started from Q0, some are started from Q1. These are the outputs. PLC, it is also passive element. It requires 24 volt as well as 0 volt. So first I'll give a DC 24 volt and 0 volt. Then the inputs from the sensors, I'll attach the input from the sensors, output goes to the solenoid valve, A plus and A minus. Suppose this is a very friendly software. You can delete anything, you can move, copy, paste, everything. Just you right click, you can understand. And here the inputs are sensors. Okay, I can use, this is the magnetic sensor. Here he has mentioned magnetic sensor, optical sensor, inductive sensor. Magnetics for sensor, there are two inputs, 0 volt and 24 volt, one output to the PLC. So output means what? 24 volt or otherwise 0 volt. Okay, so 24 volt and 0 volt. This is a sensor. The name, I have to mention name here, otherwise and the software is not understanding anything. Here S1, here S1. and arrow mark, it shows the arrow mark already S1 is on. When the S1 is on, because piston is magnetic, sensor is also a read sensor, so that magnetic flux is producing, EMF is producing, that is a 24 volt giving to the PLC. And one more sensor is required for I2. Okay. You can give anywhere I3, but while writing the programming, you should understand I have skipped the I2 and I have attached I3. Otherwise, you can give serially, no issue. I can give I2. And here also 24 volt. And this is not output. Whatever I have shown here, this is wrong. The output is here. Otherwise, if you give a wrong connection, it is not working. You find a troubleshooting where I have made a mistake. That is also, if something is mistake above 0 volt, 24 volt below, then it is showing, it is not working, or it is showing red lines. From the red lines, we can understand. The output is a solenoid valve. Is a solenoid valve. Sometimes library are above and below, just we have to search. So here, solenoid valve output, just 0 volt is required. And here plus minus, so if you make it plus, it off, the supply, all the options. If you make it minus, it shows all the options. Here 0 volt, and here sometimes is the plus sign indicates, here plus sign indicates the options below supply are off. Okay, so minus means it shows all the options. Here I'll write A plus, A minus. Sometimes you are giving A underscore, it is not working. If you do A minus, means A minus only. Okay, now it is not working. Even I will go for simulation, it is showing the S1 sensor is on, but there is a black box. You have to give a programming coding. Otherwise, here also for PLC there are 5 types of programming: functional block diagram, ladder programming, and other 3. And basically ladder programming is much powerful than other programming. Okay. So here this is the freely downloaded software. It is like a semi, you can it's not fully ladder programming, or otherwise fully FBD. Okay, so here it looks like a ladder, so that it is called ladder programming. Here I1, because I1, I2, I3 are the inputs to the PLC, Q1, Q2 are the output. When I1 is on means S1, I2 means S2, Q1 means A plus, Q2 means A minus. So first I'll go for simple programming. When S1 is on, A plus is on. When S2 is on, A minus is on. Okay. So programming is over. Here also you can see the simulation. When I1 is on, Q1 is on. When I2 is on, Q2 is on. Here also you can see the simulation. So now I'll go to here. I'll start a animation. It is not coming back. Somewhere we have done a mistake. Just you find the troubleshooting, because when it goes to the S2, here 24 volt, 0 volt, this sensor you see here, this sensor is not on. Why this sensor is not on? Here. Here. Yeah, because why? Because I have not given a name to this sensor. Here S1 I have given, here S2 I have not given, so that the software is not understanding. Suppose if I give S2 only, I should not give S3. Okay, so now it is working. S2. Okay. Small mistakes we are doing and we can find, no issue. Here S1, here S2, A plus. Now interfacing of PLC to the, you can interface to any bulb also, not only always piston and cylinder. For electronic students and electrical students, instrumentation students, you can attach a bulb also. Okay, so I'll show by attaching a bulb. switch, how it is up. Here I can give on delay timer. Here also the on delay timer. And when it goes to S2, the on delay timer. Here there is a digital technique. In the digital technique, PLC related on delay timer. Here off delay timer. This is off delay timer, and this is the NOT gate. This is a on delay timer. Here he has mentioned on delay. Now you can set a on delay. Instead of 3 seconds, you can set for 4 seconds. Okay, otherwise 4 seconds I'll set. Okay. Now when it goes to S2, it has to delay for 4 seconds. Means my question is A plus delay A minus. I can set a on delay timer here also. The timers are freely available in the PLC. I can set a one more timer here. Time may be different. Here 3 seconds. I have set here 4 seconds. Okay. So initially there is a 3 second. Then here 4 seconds. So like this you can use a timer. Okay. So I'll show one circuit for electrical and instrumentation, electrical, mechanical I show. And instead of one cylinder, you can attach a 2 cylinder, then B plus, B minus, then S3 and S4. Okay. Suppose I'll attach the bulb, here indicator light bulb, output is a bulb, and 0 volt. Here I'll delete this compressor. Okay. The input is a switch. Make a switch, you can go for make a switch. Otherwise, push button, the switches are available here. General switch. Here in the general switch, dependent switch. The switch we are using in our house, that is called dependent switch. Otherwise, a push button. Okay. So this is a dependent switch. In the dependent switch, to make on, also you can apply the effort. For off also you apply the effort. Now here this is a 24 volt. Now you see here PLC, but here you have to remove this. Now it is the bulb will not on because I have not written any program. So I have to write a program, ladder programming. Okay, first when S1 is on, Q1 is on. Whatever the first input is on, first output should be on. Now the bulb will be on. If you make it off, you can make it off. Okay, suppose if you go for AND gate also, just use a symbol of AND gate. Press in the press we are using a AND gate. Whenever the two buttons are on, then only it should be on. So all gates are available here. AND gate, I1, say I1, I2. When these two are on, then only Q1 is on. So here one more switch I'll use, toggle switch. Otherwise I can use a dependent switch. One more dependent switch. Now you see here, AND gate, or if you press first input, it is not on. If you press both, then only it is on. If you make it one off, the system is off. Same circuit I can go for OR gate also. So slowly basic, if you do the very basic program, then the logic will develop, and further you can go for any traffic signal control system and washing machine. Okay, anyone is on, this is on because OR gate. Okay, so like this PLC is working fine. So even you can give a suppose on delay only one switch is there, the bulb should on after 2 seconds. When the switch is on, then the bulb should be on after 3 seconds. Okay. So on delay timer I have attached. If you click after 3 seconds, it is on automatically. If you off it, on delay timer means during off, there is no any problem. Immediately it will off. Because on delay timer, but while on, it is what? On after 3 seconds. So you understand the basics, how the on delay and off delay timers are working. I'll show off delay also. So this is on delay, and below he has mentioned off delay. So off delay also, here there are two connections, always there is a confusion. Suppose if I attach above, just you check it and see the simulation. Is it working or not? Working, because green. Okay, if it's a, okay, output is coming. Suppose the below may be reset or some other function. Suppose if I attach below, then you have to check here, no output, and timer is also not working, means this is not a connection. So that we can learn ourselves, we'll make a mistakes and we learn from mistakes. So now, while on, it should on immediately because there is an off delay timer. While off, it has to off after 3 seconds. For while on, it has to on immediately. Suppose if I make it off, till off after 3 seconds. This is called off delay timer. Okay, you understand that even counters are also available here. The counters are also available in the up counter and down counter. Here counters are also available. Here on off, up and down counter. You can use any one counter, up or down. Here also there is a connection plus minus and 0. Okay, so you can go for any one connection first. Just you check it, is it proper or not? 1. Now it is not working because it has number has to reduce. So that what I'll do, I'll go for second. Now you see here it is showing 1, it is showing 2, showing 3, showing 4. Then after add 5, it has to give the output. Okay, so this connection is proper. But what about above 1 and below 1? So that it has to reset. So what I'll do, suppose I'll give the connection to above 1. Just you see that. So 1, 2, 3, 4, 5 and 6 also it is on remaining. But how to start once again counter? Just you press it. It is a reset button. I2 is a reset button. Suppose I'll set for suppose 3. After 3 in if I press 3 times switch, then only the bulb is on. And reset. So whenever I'll press 3 times, then only the bulb should be on. And how to make off? I'll make off by using, there is a push button. Here there is a push button, a spring return button, because the reset button should be operated for a fraction of a second. If you hold the reset button, it is the timer or whatever for counter is dead. You see that 1, first time I press, second time I press, third time. Whenever I press a third time, the bulb is on because I have attached the counter. But even if I press 4 times also, the bulb is remains on. After third, once again I'll go for second cycle. I'll press this, the reset button. Then 1, 2, 3. Okay, the bulb is on. After 3, how to reset? Just to press it. There is a reset. So how the counters are working. So quickly I showed the features of the software. It's a very friendly and very small MB software. And freely downloaded, and pneumatics is also available. Hydraulic. Here you see the heading fluid sim P. P means for pneumatic. If fluid sim H means what? Hydraulics. Okay. So you can download any one, hydraulics and pneumatics, and or both you can download. And here all the library are available. Otherwise, YouTube, by YouTube also, in the YouTube many people are uploaded the fluid sim. Just you write in YouTube fluid sim circuits. So from seeing the YouTube, you can practice the circuits. All the options are available here. Okay. You do any very complicated particular project also, you can do a project also. Here I have done a three cylinder problem. Okay, just I'll show because time is short, so that this 3-cylinder problem, cascading, very simple. It looks like complicated, but it is very simple. Pure pneumatic. Here no electronics and no PLC, pure pneumatic. Okay. But to develop a hardcore knowledge in the pneumatics only is very hard actually. Once you know this, the other rest of the PLC and all are easy. Okay. And even electro pneumatics also, there are 3-cylinder problem, and I have written a question also. A plus B plus C plus means first cylinder has to extend second cylinder, third cylinder. Any logic you can do by using relay, latching. Okay. So all I uploaded on the YouTube. Okay. So totally for the student perspective, it is best. So you learn, you clear your basic concepts and you improve your logic. You can create an interest in the industrial automation in the mechatronics, because all the industries are shifting from automation to industry 4.0. So for industry 4.0, this is also required. So I quickly, because 40 minutes sir has given, so nearly 240, I have completed some glimpse of mechatronics, especially pneumatics and electro pneumatics and mechatronics. If any kind of you want information, anything, I'll send my email ID and cell number. Please, you can contact me. Definitely I'll reply to you. 15 years back when I was in KIT, first we have purchased the mechatronics lab. We have set the mechatronics lab under Vatodekar sir. So from there I got interest, and even I have got some information and help from Suhas Deshmukh sir also, and we were colleague in the Saraswati College of Engineering. So by this I'll end my session. If you have any doubt, please you ask me.
Thank you, sir. Thank you so much.
Okay, sir. If any doubt, definitely. Otherwise, in the chat box, sir, can I send my cell number, sir?
Yeah, sir. Yeah, sir. You share your cell number and mail ID in the chat box.
So this is the best way we can conduct virtual labs online.
Yes.
This is this software is for instrumentation, electrical, mechanical, automobile, interdisciplinary labs.
Okay, sir. Gowri sir.
Oh, yes, sir. I'm here.
Shall we proceed to next session?
Yes, sir.
Okay, sir.
Thank you, Teli sir.
1 minute, sir. Once again, I thank
Yes.
Gauri sir, Lily sir, and organizing committee, Karad Engineering College and Walchand Engineering College, and especially my friends who are Dr. Suhas Deshmukh sir, and all the participants. Thank you, sir. Thank you, one and all.
Thank you, sir.
Thank you.
And you joined us within a very short notice. I am very sorry for it because we called you in the morning and then we decided everything. Anyway, next time we'll have an appropriate plan for an entire mechatronics training sessions and virtual labs. Okay, thank you, sir.
Yes, sir.
Our next speaker is Dr. B.S. Gowli. He is working as professor in our Walchand College of Engineering, Sangli, in Mechanical Engineering Department. He has completed his graduation in Mechanical Engineering from Government College of Engineering, Karad, and his master's from Walchand College of Engineering in Mechanical Engineering. He has completed his PhD from IIT Mumbai. He has joined as assistant professor to Walchand College of Engineering, Sangli, and now he is working on the post of professor in the same college. He has did his PhD in cryogenics. He has also worked on the positions like head of department, dean research and development, dean quality assurance, and so many other positions. He has guided more than 70 PG students, and 5 PhD students have been awarded under his guidance. 6 PhD students are ongoing right now. He has published 25 international and almost more than 50 national publications in various conferences and journals. He has completed more than 10 industrial projects. His areas of interest are cryogenics, heat transfer, fluid mechanics, computational fluid dynamics, design of thermal systems, and many more. He is a life member of IST, Indian Cryogenic Council, and Indian Society for Heat and Mass Transfer. He is also a member of ISRE, and he was president of ISRE Kolhapur Sangli subchapter in 2009 and 10. He is member of ISRE, and he has been awarded a certificate of appreciation for contributing 25 years in promoting the science of HVACR. He has worked as a member of Senate and Management Council for Shivaji University Kolhapur during 2010 to 2015. So I welcome Dr. B.S. Gowli sir once again and request him to continue the session. Sir, please.